Hey, welcome to Unknowns. Today we will be seeing about how to prepare a lawn culture. Is it important? Yes, absolutely important to prepare lawn culture. Here you can see this is an antibiotic sensitive assay, these two plates. The result is perfect because of perfect lawn preparation. Here there is an improper result because the lawn preparation is not good. Okay, so what is this lawn preparation? A bacterial lawn culture is when a bacteria are spread evenly across an agar plate to form a continued confluent growth. Okay, it is very much important for numerous assays like antibiotic sensitivity assay. This is the right way to do it. This is not the way to prepare a lawn. Bacteriophage plaque assay or PFU to count the PFU concentration. This is the perfect way to prepare the lawn so that you can count the PFUs. Here it is not the way. The soft agar, overlay agar is not well solidified, hence lawn is not proper here. Enzymes assays, if you want to assess the enzymatic activity against bacterial pathogens or any target organism, you need a perfect lawn to have a perfect zone. If your lawn is not proper or the concentration or density of the bacteria is not proper, you are not going to get the proper result. Bacteriosin production, crowd plate assay to assess the competition and bacterial growth inhibition studies. If you want to assess the efficacy of disinfectant and antiseptic against bacterial culture, you again need a perfect lawn upon which you will make wells and do the well diffusion assay. To assess UV radiation on or environmental stress studies, again you need to prepare a perfect fungal lawn. This is a perfect result, I would say. This is an UV unexposed plate from the fungal broth culture, which is being seeded as a lawn here. This is 5 minutes plate, 10 minutes plate, 15 minutes plate. When duration increases, number of fungal colony decreases very clearly. Okay, so to observe such UV radiation studies, that not only in fungi, even in the bacteria, you need to have a perfect lawn seeded to conduct the assays. Okay, so what is this lawn culture and how to do the lawn? Okay, let's see. We need a right bacterial density first of all. Too much will end up in overgrowth and patchy growth if it is very little. So I would say we aim for usually zero point 0.5 McFarland standards, which looks like slightly cloudy broth that could be used for preparing the lawn. Initially, you have to dip the sterile cotton swab in the lawn, and you have to make or you have to swab it on the surface of the agar in all four directions. This is very much important. What if you do not swab it in all four directions? I will tell you. See here. Here the student has tried to prepare a lawn only in two directions. Okay, latitudinal ways and longitudinal ways. Here also two direction. Maybe here three direction, but still there are untouched area. The gaps are there, patches are there. This should not be there. This will happen if you streak like this. This is to show how not to streak. Okay, if you are working away from the lamp Bunsen burner, if you don't care about the clean room conditions, if you are someone who keep the plates in the floor and just do this swabbing in one direction, you are ultimately going to end up in producing single or patchy lawn. So how to do a perfect lawn? Let's see. Okay, a perfect lawn culture will look something like this. Okay, there should be a flawless lawn. The growth should be uniform, and they should be confluent, something like this. Okay, here the entire plate is seeded with E. coli, whose uniform, the growth is uniform. There is no patches found. So only when you have such a uniform confluent growth, you can subject such a plates to various assays. You can make wells for well diffusion. See, this plate is actually both are same plates, the same equally seeded here, but the plate is exposed to UV. Now I can count the number of individual colonies. UV mutants, the E. coli mutants can be easily accessed here. So how to swab? Like I said, you need to swab it in all four directions. Okay, I would say open the plate near to the Bunsen burner and do this. Okay. I would say you can keep the plate very close to Bunsen burner and from top to bottom, see, this is second swabbing. First swabbing done, second swabbing. Again, rotate the plate 45 degree, third swabbing. Okay. Now the plate is rotated and then finally fourth swabbing. Rotate the plate and fourth swabbing. See, here you did it latitudinal ways, longitudinal ways, and also in two diagonal ways. Okay. Once you do swabbing like this, using this cotton swab, you have dipped in the broth. From that, once you have done the swabbing in all four directions, for sure you will get a confluent growth. I would say, again, let's watch this video. This is first swabbing. Okay, do it near to the lamp. Then 45 degree tilt, second swabbing. 45 degree tilt, third swabbing. 45 degree tilt, fourth swabbing. I would say once you are done at the fourth swabbing, after you are done with the fourth swabbing, just try to swab the circumference along the petri plate. In case if some regions at the edges, if it is untouched, I would say finally when you are done with the fourth swabbing, just coat the rim along the petri plates with one rotation and then stop swabbing and you can incubate the plates. This is the final swabbing. After this, you can do one more swabbing, something like this, and finally incubate. Okay, I would say this is a perfect way of creating a confluent plot. Hope this video is useful.